Good afternoon, dear participant. Today we will have interaction come lecture on remote sensing for crop resource assessment and monitoring. As all of you know, agriculture is a backbone of Indian economy. And for us, particularly in India, majority of population, agriculture is not an activity, it is not an enterprise, but it is a way of life. Agriculture support livelihood of large mass of people. It is changing socioeconomic environment of population due to liberalization and globalization. If we see statistic point of view, more than 70% of people living in rural area depends on agriculture for their livelihood. And out of this agriculture, 43% of Indian land mass is under agriculture. That means 329 million hectare land is there. Out of that, almost 180 or somewhere 150 million hectare land is under agriculture. Agriculture has been playing a major role. This day, because of service and industrial sector, more emphasis, little bit its contribution to GDP has come down. But nonetheless, it is still remain a main enterprise or main sector which contributes not only to the GDP growth, but also employment opportunity and also environmental security and food security. So if we see, you see around 150 million hectare land is under agriculture, means net sown area. If we talk about the current area time, food grain production in India, now it has reached almost 305 million tons this year. And horticulture production, it has reached to almost 329 million tons. So, and apart from that, agriculture contribution to GDP, it remain around 30 to 40% of the gross GDP. But one important point is that agriculture is a business or enterprise which provides large scale employment opportunity, more than 60% as on today, because large masses are employed in agriculture, whether it is direct agriculture or related food processing or other allied sector like dairying, fisheries. But it has got significance with respect to the livelihood of the Indian people, and also support sustainable development of any country. But as we are today discussing about how remote sensing or particularly satellite remote sensing helps in monitoring crop resource and the management. So first of all, a question comes to our mind. This use of satellite remote sensing has been there since 1980, initiated with the NOAA and Landsat MSS data in US, and US still we are doing fantastically well in the field of agriculture. But problem with us and the developed country like Europe and US, we are confined to, or we are facing many challenges because of diversity in the soil types, diversity in the climate regime, diversity in the physiography, diversity in the cropping system. There are more than 100 crops are practiced in India, either Kharif or Rabi season. So if you see rainfall, you will find arid region in the western Rajasthan to almost humid region in the Himachal and other area, per humid also. Soil types also will find loamy sand to alluvial, black soil, red soil, lateritic soil, all these different kind of soil support different kind of crop cultivation. Physiography also, if we see, right now we are in the mountainous region, Dehradun and Uttarakhand. It has got also desertic region, peninsula, plateau, then also some river floodplain. So there are many kind of physiography is there in India. So all different kind of physiography also hinders to certain extent making viable use of satellite data, because like in mountainous region, realizing the potential application of remote sensing for agriculture is a bit challenging, because there are terrace cultivation, small size of crop fields are there, terrace cultivation, and also there are slope and aspect. So aspect and slope that also hinders with the satellite based retrieval or satellite based capturing of the information. So because of this large diversity in agriculture, to certain extent it put challenge in front of the scientific community to make best use of satellite remote sensing. But even though with these sort of challenges, India, particularly ISRO, Indian Space Research Organization, has made great stride in the field of agriculture. If you see, majority, almost 70% of application realize with the satellite remote sensing for the agriculture. So starting from crop acreage estimation to even today crop insurance related studies, crop food processing industries, or you can say cold storage local identification of cold storage location, even more agri-business related application are now has been developed. So what with respect to if you go to geospatial technology, because satellite remote sensing does not work alone. Satellite remote sensing or remote sensing data, they are the key source of the information. Images can be made available from the satellite, and those images will be interpreted with the certain kind of in environment like GIS. Our data will be interpreted with the ground truth observation acquired from with the GPS system. So our geospatial technology, including satellite remote sensing, work as a tandem. So geospatial technology is not only the GIS, GPS or satellite sensor, but there are also ground observation, in communication technology, mobile application, some automatic weather station, or some network of the observation from this geostationary satellite, and also to certain extent in situ measurement network. All together helps to derive information on agriculture. So Earth observation, particularly satellite, they are having different kind of resolution, partial resolution, temporal resolution, and the spectral resolution. Partial resolution means kind of satellite data, how much on the ground it can resolve, with what minimum area it can able to map. So that is a partial resolution that is today available from almost 1 meter to 1 kilometer. Temporal resolution, there are satellite which makes you available images quite frequently. So means that you can acquire information about the particular agriculture area almost daily. Like geostationary satellite are there also. There are also MODIs or some other kind of satellite which have ability to capture images almost daily. Then in India, we are having also satellite like ResourceSat, advanced sweeps, which provides 5 days repeat cycle. Then we have got also OCM, it is also providing almost alternate day satellite images. So all those data are very much useful. So then spectral resolution means number of spectral band. Like we have ResourceSat satellite which has got list 4 and list 3. all these three has got 4 band. Then we have also one publicly freely available satellite data, that is Landsat, which has got almost 8 band. Then there is also Sentinel, Sentinel-1, Sentinel-2. All has got different kind of optical spectral data, as well as certain sensor which are having a microwave satellite data. Microwave means particularly microwave images in the different polarimetric with different polarimetry, VH or HS polarization. So Sentinel data is available, which has got also weekly acquisition of the satellite data. Then all those satellite data, they are fantastic, providing good information for the agriculture, covering entire globe also, because today all space agency, whether Japanese space agency, European, Chinese, Indian or NASA, all are working to have kind of satellite that can enable us to monitor agriculture. But all those data which are acquired and interpreted with certain algorithm are integrated with the GIS for visualization, analysis, input and storing this geolink data. Then these all data can be also integrated with the ground truth, because satellite image, it is only a tool. You have to interpret or translate this information into a real-time decision making or into certain application when you integrate with certain ground observation, whether soil moisture, leaf area index, or biomass, or crop yield. So these data, satellite data, need to be integrated with the ground data. Then certain application has to be developed. Then third is a GNSS. Means today we are having a constellation of satellite like IIRS, and which is named as NAVIC by our Honorable Prime Minister. So that NAVIC has the ability to monitor location. So location-based services, mobile mapping, and even also a particular activity like potential fish catch. So now based on NAVIC, a mobile application is developed which can provide easy access or route tracking for the fishermen, and also provides the ability to improve fish catch by the fishermen in the ocean. So that is process of fish catch and all those things, it is also part of agriculture. Then all three together helps to make informed decision, like related to crop insurance, or whether it is a drought monitoring or flood damage assessment, or you can say irrigation water requirement computation, how much water is required by a particular crop, or how much yield crop produce you expect from the particular area or particular field. That all can be done once you integrate ground truth, GIS, geospatial data and the satellite imagery to make certain informed decision by the policymaker, and to certain extent for the farmers. Now farmers can make use of this all advisory information which is generated from satellite for their day-to-day operation, or like sowing suitability, or when to sow crop, when to it is going to get harvested, what kind of other intervening agricultural operation which are linked to the geospatial data. So all this technology is working in a synergy mode. So if you go see, I'll tell you in brief. For land and water related, today we have ResourceSat, one which is operating in the optical domain. Then another is the ReSat, an Indian satellite, remote sensing satellite, which is operating in the microwave domain. So both these satellites are making a huge advantages or potential, has huge potential for monitoring agriculture, both during cloudy season as well as Rabi season, because whenever there is a cloud, optical satellite data like ResourceSat, they will have certain limitation. So we have launched the ReSat-1, which has got a capability to monitor even during cloudy season, because they are independent of the weather condition. Then there is another satellite for the high resolution like Cartosat, 2A, 3 and all those things. Cartosat, which are mainly useful for mapping. So even field boundary you can map to certain extent. You can map, okay, mainly useful for the cadastral level mapping, or to certain extent for the urban mapping. Then we have got ocean and scatterometer relays, or scatterometer like SCATSAT. SCATSAT has got scatterometer, and which provides you a good information about soil moisture, wind, speed, wind vector. OceanSat has got ocean color monitor, which provides information about the ocean. Apart from ocean, it also provides information about the crop growth dynamics, agriculture growth dynamics, how crop is growing. You can monitor in a large region, homogeneous region like Punjab, Haryana, or Indo-Gangetic Plain. Then there are also satellites, because these are all remote sensing satellite. They can provide information about surface condition or monitor surface feature. But unless you do not integrate this surface information with the atmospheric information, you cannot make certain informed decision making like crop production forecasting, or early warning for the drought or flood. So you require that weather related satellite together with the remote sensing satellite for better agriculture monitoring and sustainable development of agriculture. So today we are having a resolution from 1 kilometer, 1 meter to almost 1 kilometer. Now here you see in 1 meter resolution, you can see even all your car and everything parked in a particular parking area. And as you go in, resolution is okay, becoming coarser. 1 kilometer, it is useful for mainly India level or continental level monitoring. But high resolution, that is useful for field level, field scale mapping, or you can say urban parcel or urban building mapping. All those you can do with the very high resolution satellite. So particularly in agriculture, there are dearth of information possible and also being already operationalized to obtain from the satellite data. So initially it began with the crop acreage estimation, then agriculture drought assessment, horticulture crop assessment, cropping system analysis. So command area, irrigation command area monitoring means assessment of irrigation water requirement and system performance, soil mapping, land use planning. These days also nowadays with the availability of hyperspectral kind of data, one can able to detect pest and disease and also do certain kind of forecasting. Potential fishing zone or inland fishery monitoring, agriculture land monitoring. So all those applications, whatever you can think of with the operational remote sensing as well as weather related satellite can make for the agriculture. So particularly operationally, timely availability of information in agriculture is very much important for policy related decision like export import, or certain planning for the cold storage, or planning for the minimum support price. All these support price of the crops, you require very critical and timely information about the crop production statistic. So India is one of the country which has ability, which has got that operational mode, the satellite remote sensing program for the updating agriculture crop statistic at the district level. So it for achieving sustainable agriculture. So satellite images which are available either from the optical satellite data or the microwave satellite data are widely being used, particularly in India, and it is operationally being practiced by one of our center, which is institutionalized by the Indian Space Research Organization called Mahalanobis National Crop Forecast Center, which is located in Delhi. So this center has got mandate to operationally derive crop production statistic, crop acreage estimation, horticulture crop assessment, and also drought monitoring and assessment. So it is mainly done with the use of satellite remote sensing and other ancillary information. So how this work? This is all okay. Satellite remote sensing has got enough potential to derive information about agriculture and make certain kind of informed decision making or agriculture decision making. But how it works? As all of we know, satellite are working based on the certain interaction, like electromagnetic light. What they are measuring? They are measuring mainly simply the either reflected or emitted or the backscatter light from the surface feature. So if that short wave radiation which is coming from the sun, which is impinging on the different surfaces, whether it is water, agriculture, or soil, or any forest vegetation, or urban, then it reflects certain quantity of this energy, absorbs certain quantity, and transmits certain quantity. So that reflected part of energy from different surface feature is being observed by the satellite sensor in the domain from the visible, near infrared, and short wave infrared. So here you can see this 0.4 to 0.7 first. This is a visible domain. So visible light is mainly useful for the photosynthetic process. As all of we know, crop or plant makes food via photosynthesis. So CO2, carbon dioxide in presence of water converted into a carbohydrates. So plant makes food with the photosynthesis, and for the photosynthesis to occur, visible light is very much important. That is why, because of this chlorophyll pigmentation in the plants, it absorbs this visible light. So reflectance is very less than 8 or 9%. But the moment we go to the near infrared range, beyond 0.7, there is a sudden change and it reaches to the higher level. Almost 50% of light is reflected in near infrared region because of this multiple scattering which take place at the cell wall interface. If healthy crop is there, scattering will be more, so NIR get more and more scattered, so more reflectors will be there. Beyond that, there are 3 absorption band like short wave 1.4, 1.9 and 2.1. So these are the water absorption band for the short wave infrared region. So short wave infrared wavelength at 1.4, 1.9, this it is absorbed when plant is healthy with the more water content in the leaves. If water content in leaves is reduced because of drought, this reflectors goes up. So that is why all these short wave infrared, near infrared, visible, all are useful for the crop discrimination as well as water stress detection and the drought monitoring. Beyond that, there is also long wave region, energy emitted from the Earth's surface, that is a thermal infrared, which is useful for the evapotranspiration or other land surface steam temperature for the agriculture. Beyond that, then there is a microwave region, which is also useful for the crop acreage and crop discrimination. So up to not only optical, then thermal and then microwave, all have got immense potential to provide derive information related to agriculture, whether vegetation growth, soil moisture, evapotranspiration, or other parameter which are related directly with the crop growth and development. So here you can see, and there is a one common index which is called normalized difference vegetation index. So as I said, how it works, because once visible light fall on the green vegetation, because of chlorophyll pigmentation, that visible light absorb for photosynthesis process. So when absorption is very high, so reflectors will be very less. So only 8% is reflecting. But in case of near infrared, if healthy crop is there, more than 50% is scattered, reflected. So if you take this ratio NIR minus R plus NIR plus R, so it will come 0.72. That means normalized difference vegetation index will become very high. Means crop is in good healthy condition, and so if healthy crop always has got more than 0.7 NDVI. But if crop is stressed, yellow because of whether disease or lack of water or because of less nutrient deficiency, what will happen? Plant nitrogen content goes down, so yellowing of leaves, chlorophyll degradation will take place. As a result, there will be more reflectors in visible and the less reflectors in case of NI region. As a result, you will get only NDVI less than 0.2 when there is a stress agitation. So this is the principle, how it works for monitoring crop condition, NIR, visible, sphere mainly because of water absorption. If more water content in the leaves, in the plant, healthy crops, more absorption. So if potato crop is there, like potato, which has got fleshy leaves, so it absorb more shortwave infrared region, the wavelength, because of fleshy leaves. But wheat or other like berseem or some other crops which has got less water containing leaves, so it does not have much utility of shortwave infrared region. So here in overall crop monitoring, how it is practiced, because it is not like that one size suit for everyone. Like in our shoes, one size doesn't suit everyone. So similarly for Earth observation satellite data, for one particular date or particular spatial resolution is not suitable for every crop, for every region. So depending upon the kind of field size, like in USA, they are having 100 hectare field size is 100 hectare. So for them, even 1 kilometer satellite imagery available from IIRS or Modi's can enable us to classify wheat crop easily. But same cannot be possible in India. We are having a field size less than 0.25 hectare. 1/4 of the hectare is our field size. So we require satellite data which have got spatial resolution in the order of 20 or 30 meter only. 20 to 30 meter, then only we can map different crop types. But if it is there in the US and other region, you can do even with the 1 kilometer or even 300, 250 to 1 kilometer. Modi's any related image you can use easily. But we have more challenges. Many number of crops are practiced at the same time. At the same time also, we have small field size. So all this limit the application of the satellite for the crop area mapping. But for crop type parcel, like cadastral level mapping, every field level, if you want to map different crop, then you require anything imagery less than 10 meter resolution, like list 4 in our case. IRS resources list 4 satellite sensor. Then if you want to monitor crop growth means dynamics of the vegetation growth and dry matter. So overall vegetation, regional drought monitoring or that kind of crop condition assessment, you can use coarse resolution imagery, regional phenomena for entire India. But the moment you want to specify crop specific, then you need anything between the 7 to 10 days, means imagery around 15 to 20 meter spatial resolution, and every weekly satellite image for the crop specific crop condition monitoring or crop growth stage monitoring. Then yield, we require also crop specific crop growth stage and crop condition assessment together with the agriculture condition crop area. So then you will get yield estimation. So later we see how we can do crop type identification. Crop type acreage estimation mainly based on the interaction of the electromagnetic radiation with the different kind of crop types. Different crop has got different kind of leaf color, its crop geometry, its phenology, means timing of occurrence of different growth stage within the life cycle of crop plant. Then also row pacing, they are having different kind of canopy architecture. So all these affect the interaction of the electromagnetic radiation with the different kind of crops. So here I am showing you one chart. This is the list 3 image. List 3 has got 4 band: green, red, near infrared, and sphere. Now this is the one image required of advanced sweeps in the month of mid of the March. In case of Haryana, this is the mid of March, Haryana. Now we have plotted the specific spectral response of the different crops. practice in Haryana. Now you see, in the mid of March, wheat crop is in the maximum vegetative growth stage. So it has got the very highest reflectance in case of near infrared, because it is in the peak growth stage. But if you go to Haryana, there's scattered mustard crop that is almost in the harvesting stage, or harvested or in mature, almost mature. So it has got little bit less reflectance compared to the wheat. But if you go to same like Yamuna Nagar or nearby area where sugarcane is practiced, so the sugarcane is almost harvested, and then okay, some sugarcane is kept harvested and kept or stem left for the regrowth next year, like ratoon. So in March you won't find a much sugarcane area. A sugarcane is always almost harvested, and only stubble is left. So it doesn't have much reflectance in case of NI region. So because of these differences in the along the four bands, we can able to classify. So here distinct differences are there. That is why with the single date, one single date satellite image of advanced sweeps, we could able to discriminate these crops. So crop type identification and crop acreage. Because suppose your interest is to distinguish each and every crop in a region, like okay, Haryana state or Uttarakhand state, then your objective is to separate out each and every crop. So, or classifying each and every crop from the one another. That is called crop discrimination or crop type identification. But when your interest is only acreage estimation, then your whole methodology, acquisition of satellite data, your focus of research or your focus of operational application has to be depends on the target crop. Suppose you are interested in wheat acreage estimation in Haryana, then you shall acquire base suitable satellite data during base time, which can enables you to separate out wheat crop from other kind of crop. Also your ground truth you have to carry it out same time. So here acreage is only target crop. You are worried about the improving accuracy of acreage estimation of only wheat crop. You can compromise with the other crops which you are not interested. Now you see here, approach wise there are different approaches. One is boundary overlaying approach. That means whole satellite image is acquired, then only administrative boundary of a district or a particular tehsil is used to mask all pixel or all area satellite image pixel belonging to that particular administrative boundary. As you can see, this is a satellite image which is with the administrative boundary it is acquired. Then with the computerized ground truth has to be collected during when this image acquisition is taking place. Because agriculture is not a kind of activity like okay particularly soil or geological mapping or urban mapping, where okay you can take for 4 or 2 years back image and you can map it, because those are static in nature. But agriculture dynamic, it is a dynamic activity. So if you want to map particular crop type, then you should plan your ground truth data collection coinciding with the image acquisition time. So once you order the satellite data to our NRSC, at the same time when you order, you have to carry out the field work also. So this data ground truth with the GPS, where what crop is grown, what crop is okay in what stage, all those with the GPS location collect, and then identify those sites in the satellite imagery and train the maximum likelihood classifier algorithm to classify entire satellite image. So this is called supervised classification approach. So you can see here also, this is for Haryana. As I said, one single date you can map all crop, because there is a homogeneous area is there in Haryana. So we could able to map wheat, sugarcane and mustard and other crops with the advanced wheat data. But same cannot be possible. Now keep it in mind, because it is a Punjab and Haryana where okay homogeneous cropping pattern is there, where you will find mainly rice wheat is a dominant pattern. Rice in the Kharif and wheat in the Rabi season, and big field size are there. But if you go to Maharashtra, Gujarat, and other region, where you will find in a 1 hectare 4 or 5 crops are there. So you cannot use this advanced use kind of data to segregate all those kind of crops. There you require least 3 or even least 3 with the multi-date satellite, multi-date information. Multi-date least 3 data can help you to get different kind of crop classification in Gujarat, Maharashtra, where okay multi-crop region is there. You see here, okay, in Saharanpur, we have done one demo study. So, okay, don't generalize this with this map, because here we have got the right time satellite image when there are 2 rice variety. One is a basmati and one is a fine variety, coarse variety and fine variety. So one is a sabarmati, and one is a old basmati. So this variety, which were in the October end, in the distinct color, leaf color were distinct, and they were appearing distinctly in the satellite image. And we have collected brown tooth also during the same time. So we could able to separate out these 2 paddy variety. But it doesn't mean that every one single image can enables you to classify or separate out different variety. For varietal level discrimination, you need to have a more detailed or more finer spatial resolution, as well as you need to have a good spectral resolution satellite data like hyperspectrum. With hyperspectrum, to certain extent, you can derive different genotypes, discriminate genotypes as well as variety. So when there is a problem of cloud, like okay, we are a agriculture country, and our first major staple crop is rice, followed by wheat crop. So rice has got almost more than 32% land area, cultivated area, mainly cultivated in Tamil Nadu, Orissa, this Indo-Gangetic Plain, and West Bengal. So there, even West Bengal and Tamil Nadu, you will find 3 times rice. All year round, you will find rice cultivation. So there, because of cloud contamination, you cannot map okay with the optical data. So there you require some data like microwave, active microwave remote sensing data, because this data has got unique characteristic that it can view, it can see the ground independent of the weather condition, because they are radar, synthetic aperture radar. They illuminate the surface and backscatter radiation is received and observed by the sensor, because it doesn't use the emitted or reflected radiation. It has its own illuminating source, and backscatter value is only measured. So here you see different date. We have taken okay almost 7 date satellite data. The whole profile is monitored. Now at the end, when the crop is mature, so one variety is maturing early, another is maturing late. Because of that difference in the maturity time, we could able to separate out these 2 variety, coarse and fine variety, with the backscatter value derived from the radar set. So another crop is a maize, because these day maize, sorghum, sugarcane, and all these crop which are practiced mainly during the cloudy season or rainy season, Kharif season. So where cloud cover is almost very high in July and August, you cannot see anything with the optical data. So during this time, you need to have a microwave remote sensing data, particularly synthetic aperture radar. So with this radar nowadays, improvement in the not only in the satellite technology, but improvement with the processing technology or image analysis technology is also going on. So nowadays, machine learning, artificial intelligence, artificial neural network, all newer algorithms are being developed, like machine learning, random forest, support vector machine, and also decision tree. all can helps you to better classify crop with the different polarimetric satellite data available either from the Sentinel, also you can say Pulsar, or forthcoming NISA data. So different kind of, whether L band, C band, different kind of S band, different kind of synthetic microwave remote sensing data will be available in future, and that those data will help you to monitor not only the classify crop types, they will be useful to monitor different kind of crop growth, biophysical parameter, and also to certain extent soil moisture. So here you see the microwave, okay, it is perfectly fine to get the information about crop during the cloudy season, but still it is in the research stage. As you can see, okay, it cannot give right now better accuracy more than 70%. So still, okay, we have to do more vigorous effort, research and technology development effort to make this radar technology become viable for the agriculture activity. Then for this classification, that what we have seen, that is only for the small district or the taluka, or you can say small area, where okay, you can use boundary overlaying approach. But the moment operational monitoring of crop area and acreage required, you require to monitor whole nationwide wheat crop area or rice crop area. You cannot use the same boundary overlaying approach. Then you need to follow stratified sample segment approach. Stratification has to be done. Random stratified sampling. So stratification you can do based on the agroecological zone, or based on the previous season crop satellite imagery, or based on the previous historical crop proportion from the statistical crop area data, crop statistical data. So this stratification, once you stratify, then you have to execute sampling plan, the sample segment of different size, 5 by 5 kilometer or 10 by 10 kilometer. Then after sample segment, that sample segment means those sample segment, 10% of that sample segment is extracted and used for the classification. So you'll see in the detail here. You see one is for Punjab. The 5 agroecological zone are there. They are serving as a crop stratification. Then within zone there are district is there. One district. These are okay. You can say here is a 10 by 10 kilometers sample segment is there. So within one district only 10% sample segment is selected. So here you see 4 square box. These are 4 sample segment of 10 by 10 kilometers in one district. Another district also 4 or 5 or 3 like that. So that these 4 sample segment, only for that particular district satellite image is acquired, list 3, and classification is done. After this, okay, you can say 1, 2, 3, 4. Classification is done. Once classification is done for wheat 1, wheat 2, wheat 3. Now question is coming here, why wheat 1, wheat 2, wheat 3? Because if you go to the field, you will find certain wheat crop. Crop is same, wheat, gehu, but in certain field it is in the just tillering stage. Certain field it is in the almost flag leaf stage, or certain field you will find in the anthesis stage, because we have lot more variation in the time of sowing window, almost 1 and 1.5 months. Farmers, those landlord or high well-to-do farmers, they sow their crops early in the first week of November. Those poor or small farmers or marginal farmers, they don't have facilities of like tractor for land preparation or other irrigation, so they can sow their crops at the end of December also. So because of this time of sowing window variation, that growth, the crop is in different growth stages. So how you can do, you cannot acquire set image or so here what is done, different ground truth information of wheat tillering stage is termed as wheat 1, flag leaf stage is a wheat 2, or anthesis stage is a wheat 3. So different ground truth is taken, crop is same, but it is tagged as a wheat 1, wheat 2, wheat 3. then used as in classification. Then finally, this sample segment based area estimation, that is clubbed as a wheat, sugarcane, and forest, like that. And then okay, all those average proportion is taken and designated. Finally, classification is done, or you can say area estimation is done for the whole district based on the extrapolation, based on the stratification zone or the crop proportion. So this is okay. You see Haryana that okay, sample segment is there, 5 by 5 kilometer sample segment is there. The ground to data collection where wheat one, mustard, then okay, wheat two, and mustard. So it is taken. You can take nowadays. Okay, GPS is available. You can easily collect this all data with the GPS also. Then in the computer, okay, with the some algorithms, Bhattacharya distance or certain transform divergence, you can assess the class separability feature in the feature space. So once you will find that okay, separability is more, then you retain those training set. Then these all sample segment what 10% collected is classified and then aggregated for the every district to get the crop acreage. Same district wise, once okay, you'll get the crop acreage for the crop area, for the wheat crop area for the particular sample segment. They are also area weighted average to get the spectral vegetation index of the different district for the further yield model development. So that is all about the district, but okay, if coarse resolution data, that is one or two satellite imagery, but suppose because you cannot monitor each and every crop, nationwide crop monitoring, you require coarse resolution data, but you require multi-date. Like here, okay, for wheat and mustard, satellite data is acquired for the whole season. Then spectral profile is generated based on the knowledge about the phenology and calendar and crop sowing time and harvest time. Different decision rule are framed to classify the crops. So it is here not only maximum likelihood classifier approach, but decision tree classifier, where based on the knowledge base. Like knowledge here is a spectral profile or the phenology of the two crops. So now here you try to understand that. Now here this is the mustard crop. In the last week of October, it is generally sown. It reached to the peak vegetative growth stage in the December mid. Then you see, then there is a declining. Once okay, it turns yellow, flowering stage, NDVI goes down. First, because flower doesn't have chlorophyll, so NDVI goes down. Once that flowers turns to the pods, green pods are green, so green pods has got more chlorophyll content, so it adds to the further chlorophyll content, so more absorption of the by the chlorophyll absorption. As a result, NDVI goes up. Then this again, okay, because of senescence maturity, again it goes down. So you will find two peak in case of mustard, but in case of wheat only there is a one peak. So this is the critical information which can help you to discriminate mustard and wheat from one another. One has got two peak, another has got only one peak. And also this helps you to decide a correct acquisition of satellite data even if you have a single date. Like so for mustard, mustard, it is always better to have a satellite data during the flowering stage. That means mid of January. Then, but in case of wheat, it is always better to have satellite data acquisition in the mid of February or first week of March in the northern India. So these are the ideal suitable dates for acquisition of satellite data, like list 3 for the mustard and this wheat crop. Under crop acreage and production estimate project, which was taken by the Department of Agriculture and ISRO, mainly Space Application Center. So initial methodology was developed for the crop acreage for the major dominant crops in the of different 8 crops like wheat, rice, sorghum, mustard, groundnut, and cotton. So only dominant district were covered, because where okay area is less than 1000 or something is there for particular crop, it is not detectable. So only where major growing areas like okay groundnut, it is mainly practiced either in the Gujarat and to certain extent in the Anandpur. Okay, similarly cotton mainly Maharashtra, Gujarat, MP and Punjab. So for this, okay, you need not to acquire satellite imagery for whole India. Only where it is majority going, majority cultivation is there, those are being assessed and monitored. So how development is taking place? Okay, you can see for coarse resolution data, you can do well to wheat or rice kind of monitoring for advanced sweeps. Then you can do rice, okay, state level. If you are having a least 3 district level interest is district level crop acreage estimation, you can use least 3. If you are okay, even block level or mandal level, then you can use least 4, 6-meter resolution. Then better than that, you can use also quick bird. You can use space imaging satellite, quick bird, also rapid eye, which provides also field level along with the like our cartoset also. You can use these together for making a field level crop type mapping. So depending upon the interest, from OCM to even list 4, satellite data are being used for mapping different kind of crop in the India. So once you can crop, map crop, you can generate also cropping crop rotation. Means repetitive succession of crop grown on the same piece of land. That is called crop rotation or cropping system. Now rice wheat system is mainly practiced in Indo-Gangetic plain, which is green here you can see. So this kind of study here is useful for the crop diversification. You can study crop land utilization, cropping intensity, and finally you can suggest plan for the crop diversification. Because nowadays traditional rice wheat system, it is okay good, but it may not be a profitable and sustainable in longer run because of many issues like climate change, drought, and other things associated with rice wheat system. So now we have to think about the more crop diversification, which are high value crops and also has got climate resilience. So to achieve this kind of twin objective, we need to have a crop diversification plan. For that, okay, we require cropping system analysis and cropping pattern analysis. So here we can see area diversity, cultivated land utilization, all you can develop. So you see Punjab, land utilization is almost okay 80% and cropping intensity is more than 200. Means we all know Punjab, Haryana, rice wheat is practicing every parcel. They do not leave any field vacant. They are practicing crop year round, whether Kharif or Rabi. So their cropping intensity is almost 200. But that is why there is a problem of the sustainability. Because of this, okay, if you do not provide optimum allocation of the fallow land, then there is always a problem associated with the fertility and sustainability of the agriculture in a region like Punjab, Haryana, and all those things. So we, as I said, we have okay MNCFC, which is mandated to provide operational statistic on crop acreage and horticulture crop acreage. So this is a center which is located in the IIRS campus, Delhi. Some software development is also being used, FasalSoft, mobile application for the ground truth data. You can find many like sugarcane. We have developed also one sugarcane crop ground truth data application for the milk catchment areas. Like okay, many crop conditions, sugarcane crop, cotton crop information, fiber crop information system. So all those with mobile mapping, you can make photograph and analyze okay what is the stage of the crop, what is the how much area is under the crop, and FasalSoft that is mainly useful for classifying and generating this crop acreage estimation of the crop, and it is being developed by the Space Application Center and it is working at the MNCFC. There are certain limitation also, all good, but limitation in India is like that, small field size. We have very small field size, not like US and Europe where 100-hectare field are there. Another is a large diversity of crop. We have many crops in a 1 hectare field in Maharashtra or Madhya Pradesh or Gujarat. We'll find 4 or 5 crops because farmer need grain for his own consumption. Farmer need fodder for his cattle consumption. Farmer need also some cash crop like sugar cane or these. Farmer need also certain fruit crops, certain vegetable crops. So you will find 4 or 5 crops in one field. So that is why it makes you very challenging to map each and every crop with the correctness. Then also large field to field diversity. As I said, there is a large degree of variation in the time of sowing of window because of marginal farmer, poor farmer has a well-to-do farmer. If so, we have almost 1 to 1.5 month variability in the sowing time. This makes, and also the crop management practice also, because it is not like that every farmer is using very good fertilizer and irrigation management. Those poor and small farmer, they don't have access to irrigation or fertilizer, so their crop is very short stature, stunted, and not that much profit growth. So it creates problem for classification also. Practice of intercropping and mixed cropping, like in some part like in Gujarat, Rajasthan, many places, even Uttar Pradesh also, you will find wheat and mustard together. That is also, you can say, mixed cropping, growing up two seeds of 2 or more crops in the same field. That is mixed cropping. And you will find also like groundnut, bajra, 4 row of groundnut, 1 row of bajra. That is called intercropping. So this kind of cropping pattern you cannot classify or detect with the satellite sensor, with the available satellite resolution in the space orbit. We are also in the tropical monsoonal climate, so which is largely dominated by the cloud during Kharif season, so on which limit the availability of optical satellite data. So we have to rely only on the radar or synthetic aperture data for the crop classification. Other factors also like radiometrics, spatial resolution, spectral resolution, time of acquisition. That is, as I said, mustard and wheat crop. Time is very much important. If you have not knowledge about agronomy, like those who are agronomists, if you have agronomists or if you have from the farming background, you have knowledge about when crop is grown, where it is grown, then only you can do very nicely all these things. Then another area is a crop yield estimation. We can do better way crop yield estimation, which is required for formulation and implementation of policies, pricing, minimum support price, transport and storage, distribution and export import. So these are the different kind of decision which has been taken based on the advanced information of crops production if available with us. So government agency, they need crop production estimate well in advance to make certain kind of decision or policy maker. So for that, remote sensing technology is one of the most alternative option to replace traditional technology, which is at a conventional survey base. But remote sensing, because remote sensing today we are getting the observation available as and where we require, large area, even 8 times, and provides crop monitoring technique with possible extent. There is also strong relation we find with the satellite derived measure and the crop parameter. So different approaches are developed. One is a statistical simple spectral vegetation index and the yield relationship. There are also, as shown, spectral crop profile, multi-date NDVI, and generating the spectral growth profile or phenological matrices directly related with the crop yield to develop crop yield model. Most recent approaches which people have still are in the research stage is the integration of existing simulation crop model. Crop simulation model like available, which are the mathematical model to simulate behavior of crop plant as a function of management, soil, and the weather condition. You integrate with the remote sensing data, mainly the leaf area index or NDVI directly into the crop model. You can better improve the production forecast. Then there is one of the widely and operationally being practiced nowadays is a light area efficiency based model or production efficiency based model, which is based on the classical growth approach called biomass production model. So this is all about stress. If stress is there, less water content, so reflectance is more in case of short wave infrared. In case of near infrared, reflectance is more, then it is healthy crop. If reflectance goes down because of cell wall rupture or deterioration of the destruction of the cell wall, it goes down. In case of visible, as I said, chlorophyll absorption, chlorophyll deterioration will take place whenever there is a stress. As a result, less absorption of the visible wavelength, so more reflectance in case of visible light. So all this helps you to derive different kind of vegetation indices and useful in the monitoring crops. So this is already I have shown some kind of models like developing statistical model based on district level area weighted vegetation index derived from the sample segment approach. And this is one other is YT. What this YT? YT is nothing but is a multivariate regression model. Where YT is nothing but yield trend, because over the period of last 20, 30 years, if you see, there is a technology development, whether fertilizer, irrigation technology, varietal development, and other, all is growing. So there is a technology development is going on with by the tremendous research effort from the agriculture scientists. As a result, a production or yield of the crop is increasing over the period of last 20 years. So if we do not take into account this technology trend, positive trend into account, then model which are developed 20 years back may not be useful today. So we have to consider always whenever we are using this kind of statistical model for crop forecasting, technology development or technology trend is the key to make use along with the remote sensing data. So this is different agroecological zone wise for the Haryana district, different vegetation index, NDVI, and the technology trend. Yield model is developed with the satisfactory accuracy. Then ground based, we have done also for improvement. So NDVI satellite image list 3, then wheat crop, classified wheat crop, then wheat NDVI is generated. 3 by 3 pixel. Here we have taken with the GPS location. Crop cutting experiment. Like crop cutting experiment means 1 by 1 meter square wheat crop is harvested, trace and grain wheat yield is calculated per hectare. Then this is taken with the GPS, and those crop cutting experiment 1 meter square crop were harvested and grain yield is directly related with the NDVI. Here you see this to all how it is taken crop cutting experiment, trace, and finally along with the GPS location, this crop yield from the different field directly related with the remotely sensed wheat specific NDVI. So these are the different crop cutting experiment in Saharanpur district. You see NDVI image, then classification or wheat and other crops classified, only wheat NDVI image, and then finally different kind of statistical relationship like NDVI base only 43% variation is explained, but the moment we include some soil related factor, land productivity index or SIS index, it further improve. Further if we input again management like irrigation frequency and fertilizer application, it further improve the prediction power of the remote sensing along with the satellite data, along with the ancillary soil and management related information. Here you can see, so this is the yield map you can generate with the NDVI base and management and the also land productivity index. So integrated this model is there. So Here, okay, you can see all this model, it is working well, and almost okay, less than 5 quintal per hectare is the error associated with this model development. Then another approach, as I said, there is a deterministic approach, which is nowadays operationally being used with the satellite data available on the solar radiation from the geostationary satellite, FFR available from the directly MODIs or other OCM or other kind of satellite. PAR you can get directly from geostationary satellite. Then also water stress killer you can derive from the MODIs or other meteorological information. So finally, you can derive this okay as a classical growth analysis approach of photosynthetically active radiation absorption and its conversion into a yield. So you see wheat area, you can map. I have shown the methodology with the advanced sweeps. So particular 1 8 day from MODIS NDVI, then PAR, photosynthetically active radiation from the different weather station observatory and geostatistical interpolated photosynthetically active radiation calculated for every 8 day during whole wheat growing season. Then FFR from the MODIS NDVI data, some specific equation developed for the wheat crop based on ground measurement. FPAR multiply with the FFR, PAR multiply with the FFR, you can get APAR, then APAR multiply with the light efficiency, you will get the biomass. So these finally biomass multiply with the harvest index, the economic yield divided by biological yield, we will get the yield. Now you see this is the yield map of the based on the linear scaling based FFR and the specific ground truth based FFR NDVI equation. So here what we have observed, we can find or estimate crop yield of wheat within 10% accuracy of the official estimate provided by the Bureau of Economic Survey. Then advanced, as I said, advanced modeling approach is which is a research stage, that is integration of remotely sensed NDVI or LAI with the simulation model. So here climate data, mainly regional climate model, forecast, weather forecast, or the AWS, automatic weather observation, they can use as a weather driver. NBSS LUP soil map, you can use as a soil information. A remote sensing data, they can be used as a either integrated as a forcing strategy or some parameterization of initial condition. You can finally generate the map. So there are different kind of models, crop simulation model available. One of them is a DSET, Decision Support System for the Agro-Technology Transfer. So many models are available. So whether it is cirrus rice, cirrus wheat, cirrus maize, or cotton, sucrose, all different crops models are available within this DSET. You have to simply integrate remote sensing, derive information into this model along with the GIS based climate weather information and other things. So we can go ahead. Here, mainly this kind of model where you require geographic information system, crop model, that means software build program to simulate behavior of crop plant as a function of weather, soil and management, climate model, mainly global circulation model or regional climate model, which provides climatic data, forecasted or climate change scenario or weather forecasted gridded output. Okay, that can be integrated within the GIS to drive the crop model and finally forecast crop yield. So we have done for one Punjab and Haryana with a different lead time, 1 week, 15 days, or 7 days and 30 days in advance, forecasting the wheat yield at the regional scale, 5-kilometer grid. Now here you can see as we input more and more advanced forecast, weather forecast. So we could able to forecast wheat yield 40 days in advance with the more accuracy around 91% agreement index is there. So here if one station observation, if you take for the whole district and simulate crop yield with that weather observatory, it may not be accurate, but it better is to have a weather forecast. Maybe okay, long term weather forecast may not be that much accurate, but its representativeness over large area, that matters much. So partial representativeness of the weather information, that is very much important with respect to the forecasting regional and partial scale yield. So then also we can use also one of the index like the water requirement satisfaction index for the food security. So these days we all are talking about the crop specific drought monitoring, crop specific monitoring. So we can integrate remote sensing data, remote sensing data, phenology, or rainfall data from the satellite, or you can say potential evapotranspiration from satellite, and also crop type from satellite, and we can derive the water requirement satisfaction index, whether crop is in bad condition, failure, or good condition. All this information possible to derive with the satellite data. So climate change, now it is okay, burning issue. So we have done, we can do also to certain extent use of remote sensing to calibrate more crop model and study the how climate change is going to affect the crop yield. So one study, okay, what we have done here you can see. So rice and wheat, mainly in the without climate fertilization scenario, CO2 fertilization scenario, by 2080 they are going to decline by 40% in case of wheat, by rice 20% decline in wheat yield, and maize by 14%, particularly in the Dehradun Valley. So this is a what kind of climate change scenario. If you use geospatial technology along with the climate change scenario, you can assess for the developing climate resilient agriculture, or we can warn the people how okay their cropping system or crops agriculture will behave in the future. So same in case of Himachal Pradesh also same results we got. So we can see that okay there would be a significant decline in the yield of the crops, mainly the wheat, during in the 2000 by 2080 up to okay short term up to 2030. We don't see much decline in the yield, but surely there will be a decline in the yield, drastic decline in the yield beyond 2050. So drought is also another important. So we have developed a very good national agriculture drought monitoring assessment system. So there, this all satellite remote sensing data is being used to derive agriculture drought information. So agriculture drought affect not only crop, it leads to the fodder storage, unemployment, cattle starvation, all you can see different kind of severe effect on the agriculture sector. So how we can do this drought monitoring? Mainly drought monitoring you can do with the satellite like okay optical satellite or microwave satellite. Here the moment okay rainfall is there or the moment rainfall is not there, it recharges the soil water root zone, then this water is being taken up by the roots of the plants and it goes to via xylem, it goes to the leaves. Then leaves okay water potential increase, then water will leaves exist from the stomata to the atmosphere. Then okay once one molecule of this water exists, one molecule of CO2 carbon dioxide get fixed by photosynthesis, then okay new dry matter and no new photosynthesis produced, and as a result finally we get resumption of the new growth. Once this new growth is resumed, then it is detected by the satellite sensor. So that is why there is a time lag of 10 to 15 days associated with the drought event occurs and it is detected by the satellite sensor. That is why optical sensor like NDVI or any optical satellite data has got time lag of certain things to detect the agriculture drought. Agriculture drought, no IHR, Terra Modis, Indian remote sensing satellite, advanced WIFs or WIFs and OCM, all are being used for the agriculture drought monitoring. So here approach is that mainly optical data is mainly useful for the crop condition assessment. Microwave data is useful for the soil moisture. Crop zone area also done to certain extent with the optical satellite data. Then also weather data and automatic weather station and geostationary satellite data are a part of the generating information on weather data, all integrated to derive drought declaration and manage it. So here you can see initially a meteorological indicator were being used, mainly standardized precipitation index, farmer drought severity index, but the moment satellite data available in the history long term, so we could able to compute vegetation condition index, national vegetation anomaly index, partial vegetation drought index, or now with the surface temperature information also we could able to generate vegetation temperature condition index also. And then also to certain extent we can develop certain kind of relationship like ISRO NDI relationship, NDI SPI time lag relationship, or some Markov random field model to predict the drought. And also we can do like WRSC or integration of crop model, and this weather research forecasting model, climate model for the better forecasting of the drought stress. So here you can see this NDI anomaly index. 2002, the whole year was a drought year, so all is yellow, negative NDI anomaly. But in case of this 2001, it is a positive anomaly. Year 2003 is a positive anomaly. That means there was no drought. Drought has this anomaly is a good indicator of the any shortfall in the food grain production. We can easily forecast with this kind of NDI anomaly index. You can see this shortfall crop loss detection can easily be possible with this kind of seasonal vegetation anomaly index. So here you see 2002 all yellow. That means drought is there, very much prevalent was there drought. Then another index like in Gujarat, we could able to do vegetation temperature condition index, and it is very well useful for the drought monitoring, and also we can derive drought duration, which is directly related with the groundnut yield. So with groundnut yield, we can directly detect or how much groundnut yield is there, we can do with the drought stress duration. So that is all about this National Agriculture Drought Monitoring Assessment, where we are operationally district level monitoring of the agriculture drought is happening, where resource set, advanced WIFs data, NOHR 1 kilometer NDI data for crop condition, motion set OCM for crop condition, Terra Modis for the surface wetness, Terra MSR for the soil moisture, INSET for the NDI, this crop condition. Now also soil water balance and other rainfall data are being used for the drought monitoring. But nowadays, new drought manual is there, which is being practiced now most of the state. Yes, drought is a state business. So state all methodology, these tools, techniques being developed by the remote sensing community, and it is given to the final state to implement on the ground for the monitoring of agriculture drought. So this is a way, three trigger are being monitored. First based on only the rainfall data, then secondly based on the different remote sensing data, which can be useful further, finally the ground truth data for the verification. So that was all about drought, but as I said, then drought, agriculture drought, fasal, that is a forecasting agriculture crop output. Second is the National Agriculture Drought Monitoring and Assessment. Third is the KISAR, the crop insurance. So for crop insurance also Mahanabolis and our Indian Space Research Organization is working to derive different pest, disease, hailstorm, nutrient stress or water stress, or different stress, crop stress, biotic crop stress detection with the hyperspectral imaging or UAV or drone are being used and planned for the monitoring at field level to assess the crop loss and crop damage at field scale for the compensation, assessing the compensation claim by the farmers. So then also that horticulture crop assessment also, apple crop suitability or this jute crop suitability, a different orange cultivation or potato, onion, different remote sensing cell is being established to have information about horticulture crop estimation in different part of the country, like Gujarat, MP, TN, MH, AP. All vegetables and fruit crops, mainly mango, banana, and citrus, are being monitored with the different remote sensing cell are being established in Maharashtra or also Simla, this Himachal Pradesh for potato. So they are working to derive the crop specific, what is the crop specific statistic and monitoring. Then agro advisory also, with the geostationary satellite data, you can derive the crop condition assessment, you can see soil suitability assessment, and also to certain extent water requirement satisfaction index is computed with the geostationary satellite data, and it can be made useful for the agro-mate advisory service under Gramin Krishi Mausam Seva program. So this is all about what agriculture in remote sensing and geospatial technology can do for agriculture. But still, challenge is that if at all we want to do agriculture monitoring for the some field scale or application like crop insurance, we need to have a satellite capability of 50 to 100 meter daily, 15 to 30 meter every 5 days, or 5 to 10 meter every 10 days, or constellation of satellite like ResoSat, 4 or 5 satellite at a time, so we can reduce the frequency repeat cycle and also improve the partial resolution. At the same time, weather is equally important for monitoring agriculture, because agriculture take place under the open sky. Farmer doesn't have control, or farmer do not have a switch in his hand to adapt its agriculture to the better weather condition. So weather information is equally important and to be integrated with this remote sensing satellite for the better monitoring of agriculture and finally achieving sustainability of agriculture for our farmer. Thank you all.